I think we're set. Okay, so what I just did here, I'll start again. What I just did here is I went to a new window. I typed in New York City vital statistics. What does vital statistics mean? Anybody want to hazard a guess what that means? Vital statistics.
Like life statistics.
Yeah, exactly. Vital, vita, life. Exactly right. New York City collects data on data on illnesses, mortality, diseases, population demographics, you name it. They collect data on it, and they issue a report every year. Annual report, vital statistics report. Here we go. There's a number of reports there. This is basically a summary of. Oops, I got to New York State. I didn't want New York State. I want New York City vital statistics. And New York State duplicates everything New York City does. They do it for everything. Okay, here's a summary.
New York State mimics what the city does.
Oh yeah, on everything, and except they do it for the entire state, but they include the city statistics in it, and they overlap a lot of stuff. And I'm dealing right now with we had a Legionnaire's disease outbreak in 2015 that was pretty widespread in the Bronx. I'm sure you read about it. And the New York City put together a registration portal on the web where owners of buildings had to report and register their cooling towers, and the state also put a portal on the web, and they didn't get together when they created them. So the city did theirs first, and then the state did theirs, and all they did was copy the cities. However, rather than make a deal with the city to share information on cooling towers in the city, because probably 90% of cooling towers in the city anyway, they set up their own portal separately. So now if you own a building, you have to register, answer exactly the same questions on both websites, and get two registration numbers, one for the city, one for the state. Exactly the same information. So at any rate, this is the cover page on the vital statistics for New York City. It's pretty interesting stuff. Take a look at this. It has a summary of the deaths per thousand population, the mortality rate, the crude mortality rate, just the number of people that died per thousand in New York City since 1800. Okay, and if you follow this line, things are getting better, right? Look at this. As you go down, all the way down here, 10 per thousand, roughly now, where it used to be 30, 40, 50 per thousand. And if you look at the peaks here, they're associated with various outbreaks of disease, cholera, a cholera epidemic, a measles epidemic, yellow fever down here, smallpox epidemic. Each one of these peaks is associated with something. The last big peak here is influenza. That's the 1918, that's the flu after following World War I, the pandemic flu that we had during World War I. And what they're afraid of is that you might see another peak down here in the future. Right, for the same reason, because every year, if there's a new strain of the flu that looks like it might be particularly virulent or easy to transmit, they're always worried that they might have an outbreak that might be as bad as this or even worse than this, might get another peak as well. Okay, and if you look very carefully down here, today is September 11th, is 9/11, right? They were reading the names in the memorial downtown, as a memorial downtown. If you look at 2011, that's actually a smooth curve because they chose not to include the 3,000 people that died in New York City on 9/11. If they had included them, it would have actually looked like a bump like that. You would have seen a bump in the graph there, right? So pretty interesting. So anyway, but all this data is summarized in here. The crude mortality due to different causes and so on and so forth. And you guys can go through this on your own. This is just one of the sources of data about disease and health and so on and so forth in New York City that are going to be available to us. Okay, this other one that I told you about, I'll open that up when we get closer to the time when we're doing our projects. I'll open that up here. Leading causes of death, all ages. This is a number of deaths, male and female, from diseases of the heart in New York City. This is the total number of deaths in New York City. So a big percentage of them were from cancers, malignant neoplasms, or from heart disease compared to the others. And you can see Influenza and pneumonia, because is a has a higher rate of mortality than many of these other diseases, diabetes and so on. So, although, yeah, a lot of these, like diabetes, have contributed to some of the other causes of death, like diabetes contributes to heart disease and so on. A little bit hard to separate that a bit. Okay, Alzheimer's disease, major cause of death, right? Certainly up there with some of these others. So they also rank it. They also break the data down by age. So we could, for instance, if we wanted to, we could go through this and find out how many deaths there were from, for instance, from diseases of the heart, from cardiovascular diseases. There were 15 among people that were 15 to 24. Among people that were 25 to 34, there were, let's see, it should go up a little bit, I think, here. There were 75. And as we get into older age ranges, the numbers are going to get higher and higher. 65, 74, it was the number two cause of death, 2,700. As we get older, 85, it's the number one cause of death, right, among people that are greater than 85 years old. Disease of the cardiovascular system. Okay, so you can actually look at this data and compare how different age groups, and it's also broken down by either all deaths or male and female deaths. So you can compare male and female deaths from various specific causes in New York City. See if more men than women die from heart disease, for instance, in New York City. Okay, so I'm going to put this aside for now, and I'm going to come back to it in a little while. But before that, I'm going to start up Excel. And actually, I'm gonna put this stuff into a folder so I can organize it a little bit better. I'm going to take a file that's on Blackboard. Now, you guys that are relatively new to this, you can right-click on the files on Blackboard and say Save As, and navigate to the desktop on your computers and save the file on the desktop. If you come in here at 12:01 tomorrow morning, 1 minute after midnight tomorrow morning, these machines reboot and they'll be gone. But it'll stay there for today, right? So you'll have it available on your desktop. If you work with, obviously, on your own computer, it'll be there for as long as you want it. Okay, so, but here, you might want to save it to your desktop. The reason why I say that is because browsers sometimes do funny things when you double click on a file. A lot of times when you open a file in a browser, instead of an Excel file, for instance, an Explorer, instead of opening Excel and opening the file, it'll open it in the browser window, right? So you can read it, but you can't do anything with it because you're in the browser window, you're not in a program, right? So sometimes it's better to just go ahead and copy it to the desktop. Okay, so first I'm going to do is I'm going to go in here and I'm going to get a file here. I think I got what I want here. Okay, once again, for some reason, Microsoft has gotten really bonkers on my computer. Okay, so here we go. Here's a data set. This is 18 numbers. It might even be the same 18 numbers on the homework. I hope not. No, they're different 18 numbers. Okay, there's 18 numbers there, right? So we know that there are certain statistics, certain descriptions, certain ways we have now, descriptive statistics that we have to describe the middle of this group of numbers and the variability of the spread of this group of numbers. So give me a couple of things that describe middle. Mean, right? What else? Median, good. Median, what else?
Mode.
Bingo, here we go. Good, excellent. Okay. There were one or two other oddball ones. Well, okay, hang on a second. That's not the middle anymore. That's the variability, right? So range. You got that right, though. Another variability. Got the range. Yeah, interquartile range. Good. I like that. Okay. What else?
Variance.
Variance. Good. And the ugly stepchild of variance. The square root of it, the standard deviation, right? Okay, there we go. Okay, so we've got standard deviation.
Like 25th and 75th.
Yeah, well, we're about to do that because that's really the interquartile range, right? It's the difference between those two. Okay, so let's take a look at this. Now, one of the things you were asked to do in the homework is to calculate these. There might have been one or two others, but I think these are really the ones that we asked you to calculate. You could do what we did during our first meeting 2 weeks ago, and that is exhaustively go through the average and find the difference between each and square it, another column square it, and so on and so forth. But for the homework, it's perfectly okay to use the built-in functions in Excel. So I'm going to type in here, I'm going to click an equal sign, and I know there's not one for mean, but there is one called average. Same thing as the mean. Okay, when I hit parentheses, it comes up and helps me out a little bit with the what it wants in the way of parameters for that function, average. And it just wants all of the numbers, the list of numbers. So average, parentheses, it's gonna be from the location of those numbers I want to find the average of are between A2 colon, A19. That's the range of 18 numbers. Okay, I could either just type in A2 colon, A19. It doesn't care upper lowercase, A19, or what's even a little bit better because it keeps me from making a typo is just click in the first box without lifting and then drag down and it'll fill in that range of numbers. Now notice you could have an array of numbers that's actually goes, covers a bigger block, like even horizontally. In our case, that's the numbers themselves. Okay, close parentheses and hit enter, and that's our mean for this particular sample. Okay, what is it? How would we determine? What would we call that? We call that X bar. Okay, X bar, I mean, I can't draw a bar over the top of my X very easily here. So I'm just, instead of that, imagine an X with a bar over the top of it, I'm just calling it X bar. Well, median, we have a function for median. Equals median, parentheses, and once again. And there's the median. They're pretty close to one another. What does that suggest to you? Suggests to you it seems like it could be a, sure, equals median, MEDIAN, parentheses. As soon as I hit parentheses, you'll see it gives a little bit, you know that it's a real function because that came up, and that it's waiting for the numbers. And from A2 to A19.
You just drag it in the first one.
Yeah, you could type them in. You don't have to do that, right? Now mode equals mode, parentheses. And look, there is a function called mode. Okay, I'm going to click in here, and I'm going to drag down to 19, and the mode is 104. Well, I'm going to test that. I'm going to take these numbers.
You have to put parentheses.
Yes, you have to put parentheses in there. Now, sometimes you can get away with closing the parentheses, but it's good practice to do it anyway. I'm going to go highlight all of these numbers. I'm going to hit Control C, Command C on a Mac, or Control C on a PC, or edit and copy, and I'm going to paste them over here, somewhere out of the way. Paste. Okay, I use Control V. I could have said edit and paste if I wanted to. Okay, so I pasted them over there. The reason why I pasted them over there is because I'm going to go up here to my tools, to my data, and say, let's sort that column of numbers that I have highlighted right now. And do I want to expand the selection to cover all of these rows? That's a no, right? I don't want to do that because I just want to sort that group of numbers. If I was sorting two columns that were next to each other, where it was a patient number, patient's weight, patient's BMI, patient's blood pressure, I would want to expand that because I wouldn't want to separate that column from the patient that it worked with. In this case, I'm just sorting a column of numbers. So I don't want to, I'll just sort that. Okay, so I'm going to sort them. Let's see, sort by column G, smallest to largest. Sounds good to me. Okay, so which number here occurs most frequently? Yeah, there it is, 104. That's the mode, right? Okay, so so that is a range. So now let's take a look at the range, right? Well, I don't think there's a function in here called range. See, nothing came up, so there's no function in there called range. But there is a function in there called minimum and max, min and max equals. And what? Now I'm gonna get a little bit tricky here. I could just type in min parentheses and put the range of numbers in there, right? And that'll give me the minimum. Then I could go another box and calculate the equals max parentheses, get the maximum, and subtract the maximum from the minimum and get the range. I'm going to do it in one step. I'm going to get a little tricky here. I'm going to say max, parentheses, and I'm going to highlight all these numbers. That will give me the maximum value minus min, parentheses, and all of those numbers. So I'm going to do it in one step. Close parentheses, enter, 26. I would have gotten the same thing if I did them separately and subtracted one from the other. Am I in your way there?
No,
Okay.
thank you.
Okay, so interquartile range, I got the same problem. I don't think there is a function in there equals interquartile. No, trust me, there isn't. How about IQR? You would think there would be one in there, right? You could actually go, pull this window up and go through all the statistical functions, see if you can find one. I don't remember there being one. I don't think there is one. Okay, so instead of doing that, I'm going to calculate the 25th percentile and the 75th. Actually, I'm going to put the 75th percentile on top and the 25th percentile. Whoops. 25th percentile. And then I'm going to calculate the interquartile range right down here. Oops. IQR. Okay. I'm just going to center all of these things. Okay, so let's calculate the 75th percentile. It's equal to percentile. I know that is. Now notice that there's a lot of different versions of percentile. If you went into the instructions for each one of these things, each one is tailored for a specific kind of special application, but the original function is down here to percentile, just simply percentile. You can use that for our purposes. Parentheses, 75th percentile. Okay, I'm going to put the range of numbers in there. They call it an array, array, K, and the K is the percentile. And you describe that as a proportion, 0.75. Hit enter, and it's 104. The 25th percentile, parentheses, the same array or range of numbers. Whoops. I hope I didn't upload that. Did I? Whoa. What happened here? Comma. I'm recording this, by the way, so you'll be able to open this up at home and then use it kind of as either as instruction or background noise, either one. Enter, and there's the difference. And now the interquartile range is going to be the 75th percentile minus the 25th percentile. And so 50%, the middle 50% of values here are between 94.5 and 104, right? An interquartile range of 9.5. So it's saying that between 94.5, right? Somewhere in there up to 104 is the middle values, the middle group of values. Maybe not including all of those 104s, right? But it'd be in that range. Again, it does a funny way of calculating it. It's a little bit different than SPSS. So, but I wouldn't worry about the difference too much. You're probably not really going to use Excel for calculating interquartile range if you have SPSS or some other statistical software. How about variance? In fact, there is a function, variance, parentheses, close parentheses. That's our variance, and of course our standard deviation. There's two ways I could do that. One way is equals square root. Oops. This equal sign square root of the variance, right? Or I could use the function that's built in here, standard deviation. Happens to be STDEV, parentheses. Now I've been doing this for too long, so obviously I remember these. You could always go up to the list and seek them out, or just type them in and take your best guess and type them in. And I think most of the time you can be able to get to it pretty easily. So standard deviation, I'm going to hit enter. And we got the same numbers we did just taking the square root. No big surprise, right? So it's that simple. You could use SPSS for these basic statistical functions. Well, wait a second. What about this over here? What do I have here? Bins and count. The count is the number of numbers that are represented between these two values, 85 and 89. So I could, there is a way to do this in Excel, create a histogram by having it create the bins for you. It's so cumbersome that nobody in the right mind would ever use it. Okay, however, it's easy enough for us to say, okay, well, let's see. 80, 85, 88, we have two people that are in that range. 90 to 94. All right, we got three people in that range. 95 to 99. 95, 99. I'm going to use a function here, count, parentheses, 95 through 99, those numbers, 4. Right, doesn't matter. I could just count them by hand if I want to. 100 to 104. 100 to 104, there's 5 values in that range. Okay, and 105 to 109, 1, 2, that's 2. 110 to 114, there's none in that group.
I think it's 3 in there.
Which one? 105 to 109?
109 is twice.
109. I got lost there. Oh, yeah, you're right. What am I doing here? That's 3. Am I right? 3? 105, 106. Oh, yep, you're right. 3, 0, and then there's 1. That's 114. Okay, so now let's say.
No, it should be the other way.
Did I do? Oh, you're right. You're right. You're right. Yep. Okay. You know, you get dizzy when you do this too often. Okay, so at any rate, now there is a graphing function built into Excel. Would I expect you to do your statistical graphs in Excel? Well, kind of yes and no, because Excel has a lot of ways to customize charts and graphs. And sometimes some students prefer doing it in Excel if they've been practicing in Excel. Now, a lot of people, because Excel is so accessible, a lot of people went all the way through high school and college at this stage using Excel and using it to produce graphics. A lot of people are more comfortable using Excel than they are using SPSS and then going into SPSS and modifying their charts in SPSS. Some people feel more comfortable with Excel. I'm going to just produce a histogram in Excel. Okay, I'm going to highlight these 2 rows of numbers. This is basically names. These are labels for the values, 85 to 89, and so on and so forth. So I want to create a bar chart, a column chart they call it in Excel. So I'm going to go into charts, and I'm going to say column chart, and just a simple chart, and there we go. There's our histogram. What's wrong with this histogram? Yeah, the bars are spread out. They really shouldn't be spread out because there are no values in there. They should butt up against each other. And in fact, if you go in here, you'll see that there is a place where you can set the gap width. And if you change that to a 0, right, you'll get a true histogram. We don't need that, I don't think. And you can give a title to this and so on and so forth. So it's histogram, right? Right? You can see, now, if I asked you, where is the median value in this histogram? Right? How many people were in this study? Anybody remember? A2 to A19, that's 18 people, right? So where is the middle person? Middle person doesn't really exist. He's between 9 and 10, right? Okay, well, where is the 9th person? Well, the first 2 people are in this bar. There's 3 in here, so we got 5 people here, right? Then we have 9, if we include the 4th, we got 9 people here. So there's 9 people here and 9 people here. So really, the median is between these 2 bars, right? Where's the 25th percentile? Which one's the 25th percentile? 25th percentile would be, let me think, 25th percentile would be, if the 9th and between 9 and a half of that, 18 people divided by 4 would be 16, 4 3/4. right? So to be like the four and three quarters person. Well, in this case, I actually can define a bar, can I? Because this is the first two people. These are the next three. So the four and three quarter person would be in this bar, in the bar 90 to 94, right? Similarly, working back the other way, the the top four people would be in here. So the next person would be in the bar 200, 100 to 104. So the 75th percentile person would be in this bar, and the 25th percentile person would be in this bar, right? And the median person would kind of be between these two bars. Basically, what I'm doing here is the same thing that you're doing in the president's graph. You're playing around with the idea of where would that median person be, that president. Let me see if I can find it. I have so many versions of this. I just created a new one because we got a new president. I don't remember the name of the. I think President's Agent Inauguration. Nope, I missed it. It's not that bad.
It says U.S. President.
U.S. President.
At inauguration.
U.S. Okay, why can't I find it now? How about they created? I'm just going to go to. I'm going to. I'm going to go. I'm going to go here and just grab it. Should be in the assignments, I guess, right? Assignments. Oh, no spaces. Okay, it's 45 presidents, right? So which is the middle president? Which president is the middle president? It's going to be 22, 20, 22 on high end, 22. It's going to be the 23rd president. So where's the 23rd president? Where's the two youngest presidents? Here's, if I include this bar, which is 7, this is the 7 youngest presidents. If I include this bar, that's 13 and 7 is 20. We still haven't gotten to the median. So the 23rd president is going to be in this bar, 55 to 59. Okay, so I'll leave it up to you guys to tinker around with the other whatever else that we asked for. For instance, another thing I asked for was a conditional probability. Okay, where I asked you, what's the probability, given that a president is over, I'm going to reword it so it's not the same. Given that a president is under 50, what's the probability that he was between 40 and 44? Well, under 50 is only these two columns. So there were 9 presidents that were under 50. Given that they were within this group of 9 presidents, what's the probability that they were between 40 and 44? There's only 2 out of the 9. So the probability is 2 divided by 9, whatever that comes out to be, 0.24 or something like that, 0.23, 23% or 0.23 or something like that. So that's basically what I'm asking you for there, just to interpret that histogram. It's kind of lame, I understand that, but I mean, just so that I give you a chance to look at a histogram and try and understand the idea that the height of the bar represents the number of people or number of observations.
That's the type of question that might be on the test.
Yeah, I might throw something like that on the test. Yes.
Can you just go over the percentile, like how you see find the percentile?
Okay. Well, where would you say the 10th percentile is? How many presidents are here? Right. So the 10th percentile, 10% of the presidents would be the 4th or 5th president, right? So where's the 4th or 5th president, oldest president here? He's not in the first bar because those are the 2 youngest. It's going to be in this bar. right? This is going to be the 3rd to 9th oldest president. So the president who represents the 10th percentile is going to be in here, right? So if I asked you the 30th percentile, that would be 30% of 45 is, God only knows, is, is 12 and 13 and a half, right? So where is the 13th president, 13th oldest president? Well, this is the 9th. It's going to be in this bar over here because, the 10th through the 23rd oldest presidents are in this bar. So the president that represents the 30th percentile is going to be in here. It's going to be at the bottom end, but he's going to be in here. So that's kind of like what I was aiming for there. Okay, so now let's look at this from another perspective. Let's take a look at this from the perspective of doing this kind of descriptive statistics in SPSS. Okay, now one of the things I gave you here on the exercise stuff was I gave you this same data in another form. Okay, and that is stripped of all the extra extraneous stuff, like for instance, the different boxes that I drew and the bin stuff. Okay, and I did that to show you that we could take this data and import it as an Excel file into SPSS. Okay, so notice that the top number, there's 18 values here. The top number, A1, is one of the pieces of data, right? When I import this into SPSS, it's going to ask me, should I assume that that top cell is the name of the variable? Because a lot of times, in Excel, you might do something like this. I'm going to call this blood pressure, BP, right? I might put the label on top of that row. When you import it into SPSS, it would ask you if you want to include that as a label or as data. So before, I would have said, no, that's data. Don't include that as a label, that first value at the top of the row. Now is different, right? So I'm going to save this. I'm going to save it as a different name because it's different than you. You're going to be doing something different because now I've changed this. I'm going to call this test data. Okay, the only thing that's going to change is the way I answer that question in SPSS. So now I'm going to open up SPSS. SPSS has I don't know about version 25, but the older versions, 22, 21, they're a little bit funky. They don't like to open files that are already open in another application. So I'm going to quit Excel. Okay. So now this window, which I don't click away, don't show. You can click this, don't show this dialog in the future if you want. I don't do it because in case you see it and you wonder what it is, I can tell you what it is. I'm going to say File, Open, Data. I'm going to navigate to the desktop, and I'm going to look for that test data file that I just created. I don't see it on the desktop. Anybody want to hazard a guess why I don't see it on the desktop? What kind of file was it? Excel. And what is this looking for right now? It's looking only for its own files, files of type .sav, right? Excel file. I'm going to change that to Excel file. So now you can see the Excel files that are on my desktop, right? And there is my test data, the one I just saved, right? You couldn't see it until you changed it. And you could also, if you wanted to, you could say File, Open, Data. And you could tell it to look for all files. Just show me all files, right? So it can get a little cluttered. That's why one of the reasons why you might want to take advantage of that. Like right now, I don't know where the hell, there it is over there. So I'm going to double click on that and open it up in SPSS. So it will be imported in SPSS. And as I mentioned, first thing it says, hey, I see this descriptive, the name of the file is descriptive exercise 1, A1 through A19. Oh, I didn't save the file in Excel. Shit. Okay. So I didn't save that BP, did I? Right? I didn't save that BP. So it sees data between A1 and A19. Oh, no, wait a second. I did. There it is. See BP? I did. Okay. It would have been A1 through A18. Right. Otherwise. Okay. So it's read variable name from the first row of data. Your set of data that I left you, you would leave that unclicked, right? Because otherwise, and it'll create a fake variable name, variable 1, right? Otherwise, it would see now it thinks BP is part of the data, right? So for me, I leave that click. For you, you leave it unclicked. You can do whatever is appropriate for the data that you're working with. I'm going to click OK, and it'll be imported into SPSS. And now in SPSS, I can do the same statistics I did before. Okay, and anytime you're in SPSS, you might want to click over to the variable view. Remember, there's two views here: data view and variable view. We played around with this a little bit last week. The data view is the actual data. Each column represents a variable. We only have one column in here, one variable. It happens to be blood pressure, right? BP. Okay. The variable view, there's a line, a horizontal line in the variable view for each column in the data view. And that represents a description of the variable. The variable name is BP, can only have letters and numbers, no spaces, no special characters. It's a number, numeric. It recognizes numeric. It's 3 characters wide. Bless you. You could change that if you want. And you could also give it a label. Maybe BP isn't like the best name for this. Maybe I'll call that blood pressure. Okay, so now whenever it creates a graph or a table, instead of using BP, even though BP is still a variable name, instead of using BP, it's going to use the word blood pressure, expression blood pressure, which, I could even put special characters in there, spaces you can see, and so on and so forth. And I'm going to continue across here and all the way over here. Notice that under measure, if I click in there, it gives me a choice of scalar, ordinal, or nominal. So if this is blood pressure, which of these is it? It's a numerical or scalar variable. So it guessed correctly. Okay, if it didn't guess correctly, you have to make sure that it has it correctly. I'm going to do something interesting here. I'm going to go back to variable view. I'm going to put in another variable and gender. I'm going to call that other variable gender. And that's going to be numeric also, except 1 is going to represent male and 2 is going to represent female. It comes up with a default width of 8. I don't really care. It doesn't really change anything. And I'm going to put sex of subject as the variable name, right? Then I'm going to go over here to variables, and I'm going to go across here, and I'm going to tell it that's a nominal variable, gender, male and female, right? So now I'm going to put in 1 and 2 for gender, but in order for SPSS to be able to work with this data, I need to tell it what that value means. I'm going to click into values. When I click into values, a little box appears, and I can click and notice when a numerical variable, it says none. You don't have to worry. The values are just the number, right? But in a categorical variable, nominal variable, the number is going to represent something. 1 in our case is going to represent male. I'll click add. 2 in our case is going to represent female. Just a word of caution, if you click OK here, it's not going to add female. You got to click that first and then click OK. Okay, so now it knows that 1 represents male, 2 represents female. I'm going to go back. Now, there wasn't actually any data, so I'm going to go back in there and I'm going to fudge it. I'm going to fill in data. Whoops. Ah, crap. Excuse me. Excuse me. Okay. Is it doing it for? No, it's not. Now it's going to make me do it for every one of these. Erase that. I wish I had done it right the first time. Why does it keep coming to 11? Okay, and now I'm going to go 2. Why does it keep coming up 22? Am I hitting it twice? I'm not sure why it's doing that. I'm just going to add these. I don't really care. I'm just doing this for demonstration purposes. So I don't care if the data makes any actual sense. Okay, so person number 1, subject number 1, blood pressure was 99. There happened to be male. Subject number 12, Theirs was 103, happened to be female. Okay, so now I have my variable view. I've defined my variable carefully, and I've told it if it's a categorical variable like gender, nominal categorical variable like gender, I made sure that it was identified as a nominal variable, and I told it what those values represent. I can also go over here and I can go up to view and I can toggle value labels off and on. Now they're numbers. Now I'm going to toggle the variable value labels back on, and they appear as the actual names themselves again also. Okay, so now let's do our statistics as we did before. I'm going to go up to analyze. Anytime you do, almost anytime you're doing statistics in SPSS, at least for us, you're going to be going up to this analyze tab at the top. There's a way to script this, program it, give it typed commands on how to do things, write programs, and so on and so forth. We'll play around with that a little towards the end of the semester, but for the most part, we're going to be going up here. So what are we interested in generating here? We're interested in generating descriptive statistics. First of all, maybe I'm interested in how many males and females there are. What kind of variable is that? Nominal variable. What kind of statistics do we do for nominal variables, descriptive statistics? We do frequency tables, and we do bar charts, or we do pie charts. So I'm going to go into descriptive statistics frequencies, and I'm going to tell it I want to work with the sex of the subject, gender. Now there's two variables there. You're responsible for telling SPSS what you want to work with. I'm going to move the variable gender in there for frequencies. Okay, so in here, there's a statistics function, but it's meaningless, right? That doesn't mean anything where a categorical variable is concerned. However, charts, I can ask it to produce a bar chart for me. Now I could ask it to produce a bar chart that is based on frequencies or percentages. I'll leave it on frequencies for now. Okay, and now I can tell it, well, go ahead and let's produce our descriptive statistics for this nominal variable. As soon as you do that, the output window comes up. The output window is a completely separate window in SPSS. When you quit the program, you need to save your output window if you want to save it separately from your data window, or you won't have both of them. You can also export your output window you can save it or export it as an RTF file, rich text file, basically the same thing as a Word document. Okay, now for the most part, I'm going to be asking you that when you create tables or charts, since you may be using many different versions of SPSS, I'm never going to tell you to give me your output table, your output file. I'm always going to be asking you to take your chart or your file. Notice it substituted sex or subject for gender. Okay, I'm going to ask you to take your output table and to copy and paste it into a Word document. Two reasons. One, I don't have to worry about compatibility with your output, opening your file. And number two, because that's the way you're going to be presenting data to other people in the future. You're not going to assume they have SPSS to open up your output data. You're going to give it to them in a format they can work with it. Now you can click on here, say copy, and then paste this into a Word document. Similarly here. Now some people, I know I have this problem on my Mac sometimes. Okay, some of these tables, I can't get them to copy and paste into a Word document. So if you have a Mac and you're having that problem, there's a program on your Mac called Grab. Okay, it's actually inside your utilities folder, right? If you go up to background, you go up to Go and Utilities, right? Either Applications or Utilities, I don't know which one. It's in one of those. You can take it and you can drag it down to your bar at the bottom there, so it's available for you quickly. Okay, I'm going to click on Grab, and once that comes up, it gives me the option of capturing this screen, the whole window, the whole screen, a time screen if I want to do something that is I need to press a button, I want that reaction, or just a selection. So I could click that, and I could tell that I want to copy this table, and I can save that now as a PDF file, a JPEG, a whole bunch of other TIFF file, a PNG file, and so on and so forth. Or I can just say copy. I can ignore all that. And I could just say copy, go away. Yeah. I can say copy, and I should be able to paste that into a Word document now. In case you have a problem with a version of this that is a little bit buggy or something like that. But here, there's our bar chart, right? They're not close together. This is number of males is 10, number of females is 8. You can see 10 males, 8 females. It's a count, frequency or a count. Okay, well, how about, let's go back to analyze again, descriptive statistics. So this time, let's look at our other variable we have, blood pressure. Okay, so that's a numerical variable. So I'm not going to go into frequencies, because if I go into frequencies and I try and do this for blood pressure, it's not going to make any sense. Watch what happens. Look at, well, basically, it's giving me the frequencies for every possible value. I mean, this really doesn't help us any, right? Doesn't make any sense. I need to accumulate this as data that in an organized way. So I'm going to go up to analyze descriptive statistics, and for nominal data, I'd use frequencies. For numerical data, I'm going to use descriptives. And I'm not going to move this in here, sex, right? Because I don't need an average of male and female. What doesn't make any sense. I'm going to move blood pressure into the variable. And I'm going to go into options. And look, it gives me the option of calculating the mean, standard deviation, variance, the range. There's some things that are not there, though. I'm going to click continue. I'm going to click OK. The output window will come up again, and there are our values calculated on the bottom there. Whoops. This is what I mean about, sometimes I'm working down at the bottom of the page. I'll do this again. Actually, if I raise this up, I'll be able to reach the bottom. There, you guys in the back should be able to see it a little bit better now. Are you guys using the screens now? Or I guess some of you are, right? Yeah, it helps a little bit, right? A little bit easier to see. Okay, so here is our range and so on and so forth. Oh, the class is over, isn't it? Okay, it says our range and so on. Just one more thing to show you, right? There's our median, our minimum, maximum, our range, our mean, our standard deviation. A couple of things missing here. One thing that's missing is analyze, descriptive statistics. This time I'm going to go into the next thing, explore. I'm going to do the same thing. I'm going to move blood pressure into the dependence list, right? Statistics is already checked off to do descriptive statistics. Plots, it's going to do stem and leaf, it's going to do something. I'll make it do a histogram. Okay, maybe bounce around there a little bit. Display both statistics and plots. I'll click OK. See what I get this time. Well, this time I get all these descriptive statistics. I get mean, median, confidence interval, range, interquartile range. I get all the stuff that I didn't get before. And I get a histogram plotted for me, right? I even get a box plot plotted for me for this data. The last thing I want to show you is I'm going to go back into Analyze, Descriptive Statistics, Explore, and this time, I want to compare the blood pressures of females versus males. Well, I want to break them up. And in math, when you break something up into its integral parts, you call it factoring. I'm going to take this nominal variable and move it into the factor list. Take blood pressure, break it up by the gender or sex of the subject, and now give me the means and statistics for all of those for those groups. I'm going to click OK. And this time we're going to get means and I'm sorry, I'm running a little bit late. Means and for females, and we can compare it to the means and the statistics for males. And there's a histogram for females and males, and there's a box plot. We can actually see the difference between the two. I can see some skew there and stuff like that. Why did I bring this up now with the last thing? Because you're doing exactly the same thing in the homework, except you're using a different data set. And what is it, the weight of infants at birth or something like that? And you're breaking it up into mothers that are married versus none, or the ages. I don't remember what it is, but you do exactly the same thing. You put the numerical variable in the top and the nominal variable, whether it's married or smoking status or whatever it is, the thing you're going to break it up into that second factor box.